Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we'll continue with our discussion on angles. You should have already watched my videos on creating angles, angle measure in degrees, and angle measure in radians. At this point, we're just going to convert between degrees and radians and do a couple problems there, and then move out of this. So here's the theorem, converting between the angle measures. It's not something I would actually memorize, to be very honest with you. I didn't when I was a student. 1 degree equals pi over 180 radians, and 1 radian equals 180 degrees over pi. Instead, what I did remember, and what I strongly recommend you remember, is that 360 degrees, a full rotation in a circle, as we stated last time, is the same as 2 pi radians. That's the conversion factor. 2 pi is the same thing as 360 degrees. And in fact, that begins the proof. Since there are 360 degrees in a full rotation and 2 pi radians in a full rotation, 360 degrees must be the same as 2 pi. And remember from the previous lecture, radians, you don't write the units. That's a unitless notation. If you divide both sides by 2 pi, then you'll get the following. 360 degrees over 2 pi is equal to 1. In this case, we know we're talking about angles, so that 1 means 1 radian. And of course, that fraction will reduce to 180 degrees over pi is equal to 1. And that 1 is in radians. So I'll just point an arrow at that and say radian. And that is the proof of this one right here. 1 radian is 180 degrees over pi. Well, additionally, we have the following. So I'll say also, we have that 360 degrees, again, is just 2 pi. Now, in this case, if you divide both sides by 360, not 360 degrees, but 360, you'll be left with 1 degree is equal to 2 pi over 360. That fraction will reduce. You'll have 1 degree is equal to pi over 180. The left-hand side is in degrees. The right-hand side, because it doesn't have a unit, is in radians. So let me just go ahead and put in here, radians. And that is our second part. 1 degree is pi over 180 radians. So again, when I was a student, I never really memorized these two. Instead, I just worked with one. This guy right here. I knew 360 degrees was the same thing as 2 pi, and whatever I needed to convert from or to, I would just make that unit conversion. So let's see how I would do it when I was a student. Convert angles between the measures. So this is all my way of saying make stuff up. So part A, let's make something up. Let's convert, let's do very important angles actually, 30 degrees. Let's convert 30 degrees. And that means you're going to convert it into radians. Okay. So 30 degrees, I want to change it out. So I'm just going to go ahead and go over here and write 360 degrees is the same thing as 2 pi radians. I'll divide both sides by 360 to get 1 degree is equal to 2 pi over 360, and that reduces to pi over 180. And that's how I would always do it when I was a student. I would just say, well, this is 30 times 1 degree. But I know that 1 degree is the same thing as pi over 180 radians. And pi over 180, let's see, 30 goes into 186 times. So this is pi over 6. So 30 degrees is the same as pi over 6. 30 degrees is pi over 6 radians. such an important angle that specific one you should remember. Next one, part B. Let's look at, let's do 5 pi over 4. Notice it does not have a degree sign on it, so this is a number in radians. So I need to convert from radians into degrees. Well, again, going back over here, I happen to know that 360 degrees is 2 pi radians. If I divide both sides by 2 pi and reduce, I'll have this. So I know that 1 radian is 180 degrees over pi. So I'm going to say this is 5 pi over 4 times 1, just 1 radian. And we had our conversion there. The radian, 1 radian is 180 degrees over pi. Notice here the pi's cancel. And 4 goes into 180, let's see, 45 times. So I'll go ahead and write that in here. This is 5 times 45 degrees. And 5 sets of 45 degrees, let's see, it's 90, 180, 235. 225, sorry. 225 degrees. Not bad. That's a nice clean angle. Now, they're not always going to be clean angles. Just letting you know. If I gave you something like pi over 7, well, again, that's in radians. But now that we have the unit conversions in front of us, I can just say that's pi over 7 times 1 radian. But I happen to know that 1 radian is 180 degrees over pi. The pi's do cancel, but 7 does not go into 180 nicely. So this is going to be 180 over 7 degrees, and that's about as good as it gets. I normally don't want to grab a calculator when I am lecturing, nor do I want you to grab a calculator. I want you to leave answers in exact form. That's what this is called, exact form. It's better for you to do that because anybody can grab a calculator and punch buttons. That's not the point of mathematics. The point of mathematics is to understand the symbolic manipulations that you're going through. So that's that for you. Let's go the other way around. Let's have a negative, let's do a negative 32 degrees. So negative 32 degrees, again, we're converting from degrees. So negative 32, and up above we have our conversion from degrees right there. So 32 times 1 degree, just looking at this right here. And let me get rid of that. Just pops up when my hand goes up high on the screen. 1 degree is the same thing as pi over 180 radians. So negative 32 times pi over 180. Now we're completely in radians, but I would like to reduce this down as much as possible. Let's see, negative 32 is 8 times 4 with a negative. So, and I know that 4 goes into 180 45 times. And that does not reduce any further. So that's as good as it gets. It's negative 8 pi over 45 radians. Let's see, what about 3? Like, that's not degrees, that's 3 radians. A lot of people feel as though, especially when you're going through trig for the first time, you feel as though every radian number needs to have a pi on it. That's not true. Radians don't require pi's attached to them. They could be any number. It could be 1.8. It could be, 3/7. It could be 5 pi over 4, or it could be like this, 3. So 3 radians converted to degrees. So I know 3, same thing as 3 times 1 radian. The conversion from 1 radian is 180 degrees over pi. And unfortunately, nothing cancels there. So it's just 3 times 180, and I think that's 540 degrees over pi. Whatever that may be. Okay. I did say I wanted you to see some of the common angles. So let's go ahead and go through the common angles here. So I will make a list off to the right-hand side. So 30 degrees we found out was pi over 6. Another very common angle is 60 degrees. Well, that, once you know 30 degrees, you know 6 degrees is just twice that. That's twice pi over 2. That's pi over 6. That's kind of nice. So that's pi over 3. So 60 degrees, that's just pi over 3. We know that 90 degrees, for example, was pi over 2, but you can convert that. You can see if it is 90 times 1 degree. That's 90 times, let's see, pi over 180. That is pi over 2, definitely. So 90 degrees is pi over 2. There's so many others, but only one more that I want to deal with right now. Let's deal with 45 degrees. And we saw this in an example, but it's good to see it anyway. It's 45 times 1 degree. Remember, 1 degree is the same thing as pi over 180 radians. 45 goes into 184 times, so that's pi over 4. So 45 degrees, which I didn't leave room for, so I'll just write it up above. I'll zoom in so my handwriting's not total terribleness. So we had 30 degrees was pi over 6, and 45 degrees is pi over 4. Those three angles right there, critical angles, because you can actually get pretty much every important angle from those 4 angles. Well, top 3 mainly, but you can really, honestly, you can get almost all of them just from 30 degrees and 45 degrees, because twice 30 degrees would give you 60, twice 45 degrees would give me 90. Everything else is kind of a permutation of those, but still, this is good to remember. So is this 180 degrees being pi is very important to remember. 270 degrees being 3 pi over 2, very important to remember. And 360 degrees being 2 pi, obviously incredibly important to remember. So all of those that I've highlighted, it should be committed to memory, and you should understand why they exist and why they equal those numbers, and be able to derive them if you need to. Those are all very, very important. Now, while there are as many angles that can be measured in radians as measured in degrees, we tend to focus on those very specific angles that I listed before, with the radian measure that we call special angles. So these are their degree counterparts, and we already converted some of those to angles to radians, so there's really no point in having you do it here. We know that this is equal to pi over 6. We know that 45 is equal to pi over 4. We know that 60 is equal to pi over 3. We know that 90 is equal to pi over 2. What's interesting about this is that if 30 degrees is pi over 6, oh, by the way, 180, very, very important, is pi. And I say it's very important for a very specific reason. If I told you that 30 degree angle, this angle right here, was pi over 6 radians, well then, how many radians is this? If you thought pi over 6, you're absolutely right. That totally is pi over 6 radians. It's a 30 degree angle. But the real question is, what is the angle that gets me to that? Well, you say 150 because that's what it is, 150 degrees. But the easiest way to compute that in radians is to say pi is the same thing as 6 pi over 6. Notice I'm using this denominator to help me build out pi. Pi is 6 pi over 6. I'm almost, when you rotate around this curve to get to 150 degrees, you're almost to pi, which is 6 pi over 6. You're just shy by pi over 6. You're just off by pi over 6. So you're at 6 pi over 6, but you get to subtract a pi over 6. 6 of those pi over 6s, losing a single pi over 6, this angle would be 5 pi over 6. And you could do that trick actually with all the angles. So for example, let's suppose that you wanted to get all the way over to this angle. That's 135 degrees. Well, the easiest way to find what that angle is in radians is to go as quickly as you can to the x-axis. This is called a reference angle, and we'll talk about that, I think, in the next video or the video after that, but it's just the fastest way to get to the x-axis. That reference angle right there is 45 degrees, right? It's symmetric. It's symmetric to this angle right here. Okay, so it is 45 degrees, which means that angle is pi over 4. Well, the red angle, I almost got to pi. By the way, pi is 4 pi over 4. Notice I wrote it in terms of 4s this time. So if I almost got to 4 pi over 4, but I missed it by 1, I'm at 3 pi over 4. And you could do this anywhere. This idea of using kind of the reference angle. So let's suppose that you rotated all the way over to, I don't care, this angle right here. Now we know that angle's 300 degrees. But we're shy by the fastest way to get the x-axis there. We're just off by 60 degrees. If you measure that out from 300 degrees to this edge here, that's a 60 degree angle, right? But we know that a 60 degree angle is the same thing as pi over 3. Now in this case, it's not that we're going to get to 0 degrees. We're trying to get all the way around the circle. All the way around the circle would be 2 pi, right? Okay. Well, and by the way, I wrote pi over 2. It's supposed to be pi over 3. I don't know why I wrote pi over 2. Pi over 3. Okay. Well, let's see. If I put this 2 pi in the same denominator as that pi over 3, it would be 6 pi over 3. So I almost made it all the way around the circle to 6 pi over 3, but I'm just shy by one of them. If I didn't make it all the way over and I'm just shy by 1 pi over 3, 6 pi over 3 minus 1 pi over 3, this angle, this one right here, must equal 5 pi over 3. That's what this red angle is. Again, that's how you build that out. So you could do this all day long if you want to. I don't want to. So instead, let's just hop over to the next page and say, here's the same circle, but with radians that are put in there. You can see the 5 pi over 3 right there. Now, I highly recommend you do not commit this to memory. The ones that are important to commit to memory are these 3, and obviously any of, well, I don't know if it's obvious to you, but any of the quadrantal angles, those should also be committed. But you don't need to commit all the other ones to memory because you're going to be using reference angles. In other words, you're looking at, for example, this angle right here. The easiest way to compute it is just to ask yourself, what is this angle? The fastest way to get to the x-axis. Well, that's a pi over 6. Okay, so I'm at pi plus a pi over 6. Okay, so that's 7 pi over 6. So that's how you would normally do it. And these ideas we'll expand upon as we move forward, but it is just important that you kind of get exposed to them at this point. So I hope that it's a small exposure. We didn't work with it a lot. We did do a lot of conversions, and you should be able to convert between any of these angles here, between degrees and radians, or any other angle between degrees and radians. You should be able to do it. But I think that's enough for this video.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.